Okay, in this presentation we're going to look at a probability question, a worked example. So an electronics assembly subcontractor receives resistors from two suppliers, Delta Tech and the other one is called Echelon. Now Delta Tech supplies 70% of the subcontractor's resistors while Echelon supplies the remainder, which constructively you'd think that's 30% straight away. It's implied. Now this is important, this bit here. 1% of the resistors provided by Delta Tech failed the quality control test, while 2% of the resistors from Echelon also failed the quality control test. So there's two questions here. What is the probability that a randomly chosen resistor, I should say, will fail the quality control test? And what is the probability that a resistor that fails the quality control test was supplied by Echelon? Now, this is handy to do in each case. This is if you've got a lot of time in your question, but maybe you don't have to go into the same level of detail as I do, or you don't have to write it out, but definitely have something to sort of explain your notation, okay? Because maybe it won't be as intuitive as you think. So here what I'm going to do is say D means Delta Tech, E means Echelon, F means fail the test, and P means pass the test. I don't think we're really going to use P in this particular video. Okay. Now, so a randomly chosen resistor comes from Delta Tech. The probability of that is 70%, and the probability that it comes from Echelon is 30%, 0.70 and 0.30. Now, we're given two more pieces of information, and this is crucial, this bit. This is crucial to the answering of this question here. And so the probability that a randomly chosen resistor fails the quality control test, given that it comes from Delta Tech. So how do we write that? That is the probability F given D, and that is equal to 1%. So that it fails given that it comes from Delta Tech. F given D, and likewise F given E, and that is 0.02%. Okay, so that is the important thing, to actually sort of parse the question and sort of be able to deduce what the key pieces of information are, what the conditional probability is, and what given what. Okay, what is the event that it's contingent on, the conditional probability. Okay, so just having that set up in your head is very important. And again, we're told this information here, okay, in this paragraph here. Okay, so just take a moment there just to sort of double check that are you happy with what I'm doing. Now, so the first thing we're asked to do is find out the probability of failure, probability of F. Okay, so all resistors either come from Delta Tech or Echelon. Okay, that's 100% of the resistors. Okay, so using the law of total probability, which is very important, we can express the probability of F as follows. So P of F is the probability of F and D plus the probability of F and E, intersection D intersection E. Now, essentially, if we have a big pile of resistors and we just pick out the faulty ones, so we have a big table full of faulty resistors, we might be able to tell the suppliers apart, and that means we end up with two different piles. Okay, so that's essentially our rationale is here. Now we're going to expand this a little bit further. We're going to use the multiplication rule. Probability of A and B is the probability of A given B times the probability of B. Now this is actually the multiplication rule and the conditional probability rule, I should say. So essentially what we have here is this expression here, the probability of F and D. That can be rewritten as F and D times the probability of D, conditional probability of multiplication. Likewise, the probability of F and E, and F intersection E, can be written as the probability of F given E times the probability of E. Okay, so we're actually pretty much really near the in the home straight. We actually know all of these values here. So we know that it's 1% and 70%, 2% and 30%. Okay, so that is 0.01. That's the probability of F given D. The probability of D is 70%. And likewise, 0.02, that's the probability of F given E. The probability of E is 0.30. So a little bit of calculator work, and that is 0.007 plus 0.006, and that gives us 0.013. So 1.3% of the resistors are faulty. Okay. Now, the second question asks us to compute the probability that a resistor that does fail the test was supplied by echelon. So, of the resistors that failed the test only, what is the probability that a randomly chosen resistor was supplied by echelon? Now, it's very important to sort of see what we're doing here. This is the probability of E given F. Okay. Now, what we could do here is use the Bayes rule to actually compute this. Okay. So that is the rule. Probability of A given B can be written as a probability of B given A times the probability of A divided by the probability of B. That's actually an extension of the conditional probability rule, but okay. Now we actually have, this is actually how we would express it in terms of the events that we are already discussing. The probability of E given F is equal to the probability of F given E times the probability of E divided by the probability of F. So working that out, that would work out to be 0.02 times 0.30 divided by 0.013. And that should give us, I think, 46%. I think that's a 0.460 there. Okay, 46% of the resistors should come from echelon. Even though they only provide 30, 46% of the faulty resistors come from echelon. Okay, so that's grand. We'll leave that there.